you, Andrew. And first, I would like to say I'm glad to be presenting the result of my experiment with the title of Experimental Study of the Effect of Water Spray on the Spread of Smoldering in Indonesian Peat Fires. And this experiment was written by me, Mohamad, Ramadhan, and my colleague, Peter Palamba, Mr. Fali Arimun, Mr. Mpos Amna Kosasi, and Professor Yudianto Sulisya Nugroho. And also, this research was conducted in Fire Safety Engineering Research Group, Department of Mechanical Engineering, University of Indonesia. And in this presentation, I would like to start from the background, why we choose the experiment, and the objective, literature study, experimental methods, results, and discussion until the conclusion of this experiment. Now we move on to the background. As we can see in the picture, that peatlands spread all over in Indonesia, and the peat fires still remains a big problem, especially in Sumatra, Kalimantan, and Papua Island. There are several studies on peat fire suppression. Like the first one is the trial of the dropping a ton of water from the helicopter, and also the quarrying of the peatland, and also canal blocking. And the last is a direct suppression using the water spray. But until now, we still have no idea how much the water required to fully suppress the peat fire. And here is the objective of this experiment. The first one is to know more about the smoldering combustion phenomena that happened in the Indonesian peat sample. And the second one is to find the amount of water required to fully suppress the peat fire. And we move on to the literature study. And what is smoldering combustion? Based on Kasatwi handbook, smoldering combustion is slow, low temperature, and flameless form of the combustion. And it usually happens in the condensed phase fuel, and also in the porous materials. And based on Agus Purnomo, peatland is an area that have a partly decomposed organic matter with the ash content equal or less than 35%, with the depth deeper than 50 centimeters, and have a carbon content at least 12%. And here is the classification of tropical peat made by Woods and all. As you can see in the picture, that there are several types of peat. As you can see, there are fibric, hemic, and sapric. And the morphology of each type of peat is different based on the degree of decomposition. And also, there are correlation between ash content and the carbon content of the peat. It also depends on the decomposition degree. And in this experiment, we collect the peat sample from two different places, namely South Sumatra and Papua. We expect that from the different locations, the characteristic of the peat would be significantly different also. And we collect the sample using PVC tube, and in the different depth. And after that, we insulate the PVC tube using epoxy in order to maintain the characteristic of the peat. We also conducted a scanning electron microscope to see the pore diameters of each sample. As we can see in the picture, that For the top one pit, the core diameter is approximately 13 micrometers. In other hand, for the South Sumatra, it's about 30 micrometers. And also we capture the morphology of each pit, each dry pit. As we can see that the Papua pit is finer than the South Sumatran pit. We also conduct some proximate and ultimate analysis in order to know more about the chemical compound of the pit and also the mechanical properties of the pit. In this experiment, we use the stainless steel container with the volume about 1,000 centimeters cubic. As you can see in the picture, inside the box, we use the calci board as an insulation to reduce the heat loss from the combustion process. And in the one side of it, we put 9 thermocouples to measure the center line of temperature of the pit. And we divide into 3 layers. The first layer is top layers, which is in the 25 millimeter depth, and the second layer is middle layer in the 50 millimeter depth, and the bottom layer were placed in the 75 millimeter depth. And also, vertically, we divide to the region which is the nearest from the coil heater until the furthest from the coil heater. And we place the coil heater at the left side of the box using a coil to ignite the combustion process. For the suppression experiment, we use the hydraulic atomizing nozzle with the type of Lutfi nozzle. And the working pressure for this experiment, we use about 7 bar. The experimental setup is we use the water spray nozzle, pressure gauge, pressure vessel, and also pump. And we did 2 approaches. The first one is the short period suppression, and the second one is the full suppression experiment. By doing that, we could calculate the amount of water required to fully extinguish the fire. We move on to the water spray scenarios. This is for the short period suppression. As you can see that we vary the spraying distance between 10 centimeters and also 15 centimeters. By doing that, we could vary the amount of water sprayed received by the pit bed and also the effective water field volume that received by the pit. In different, for the full suppression experiment, we only use 1 spray distance. As you can see in the scheme that we only experiment with the spraying distance about 10 centimeters. But we have 2 different criteria to be fulfilled. The first one is the water required for the temperature of pit below the oxidation temperature, or it is about 300 degrees Celsius. And the second one, the water required to fully cooling the pit or below the evaporation temperature of water. Now we move on to the result and discussion of smoldering experiment. When the igniter was activated, the temperature near the heater would increase significantly, and in the middle layer, the smoldering front would move to the furthest point, measurement point, and because of that, in the upper layer, the burnt pit would be collapsed to the layer below of it, and because of that, again, the bottom layer relatively stable with the quite high temperature because of the collapse process that I observed before. And in general, we can see that the period of smoldering combustion in South Sumatran pit were shorter than the Papuan pit. And here is the smoldering experiment data. We could get the time to ignition for each pit. It is quite similar. It's about 118 and 119 for each pit. And we could get the maximum temperature, which is the South Sumatran higher than the Papuan pit, and the mass loss of the South Sumatran pit higher than the Papuan pit because of the pore diameter, and the permeability to flow higher than the Papuan pit. And we move on to the spread rate of the smoldering. We can see that we divide the spread rate into two types. The first one is horizontal spread rate, and the second one is the vertical spread rate. For the horizontal spread rate, as you can see that the trend was decreased. As you can see in the top layer, which is the layer that has so many oxygen, it has the largest spread rate, and also in the bottom layer, it is smallest because it is lack of oxygen concentration. And for the vertical spread rate, for the spread rate near the coil heater would be have highest spread rate. Now, for the short period of separation, we have a temperature time history. It's quite different from the smoldering experiment. As you can see, for the 50 centimeters spraying distance, the water couldn't fully extinguish the combustion. As you can see, from the 50 millimeter depth, the water couldn't suppress full, and the reignition process would be happened. It is also happened in the 10 centimeters spraying distance. As you can see, the reignition process would be happen, and the pit bed will have a smoldering combustion again. This is the total mass loss data. As you can see that for each sample, the amount of mass loss is quite same with the without suppression experiment. And we move on to the result of full water suppression. This is the temperature time history for the full suppression. As you can see that the Papuan pit needs more time to fully suppress than the South Sumatran pit. It needs about 139 minutes to fully suppress, and for the South Sumatran pit, it needs about 80 minutes to fully suppress. It would be correlated with the pore diameters and permeability of both samples. And also, we calculate the water required for extinction and also the water required for cooling, which means that the water required for extinction is when the temperature measured reach below the oxidation temperature or 300 degrees Celsius. We get for the Papuan pit, it needs about 6 liters per kilogram heat. And for the South Sumatran pit, it required about 2.6 liter per kilogram peat. On the other hand, to fully suppress the water until the temperature reach below the evaporation temperature of water, or maybe about 80 degrees Celsius. For both peat, it needs about 6 liter per kilogram peat. And for the mass loss, it has already decreased compared to the other experiment. And here is the interesting thing, that if all mass loss experiment result was compared, we can see that for the without suppression experiment and source suppression experiment, it could produce the same mass loss for the sample. It is also happened for the South Sumatran peat. It's quite similar for all the mass loss in percent, but in the full suppression experiment, we could reduce much of mass of peat. And to conclude that we know the smoldering combustion is a complex phenomena, and if we apply the source suppression, it would be happen a reignition phenomena, because the short period of water could only wetting the surface of the pit, but not the core of the pit. And also, the amount of water for cooling process for each sample, it is approximately 6 liters per kilogram pit. And we could say that the short period suppression is not an effective measure for controlling smoldering pit fires. And if we want to reduce the pit fire, we have to conduct a full suppression, because it is an effective approach, and it was able to extinguish the smoldering front. And I would like to say thank you to Universitas Indonesia through the PITA program for this experiment. And thank you for your attention.
So now the floor is open for questions.
From UC Berkeley. So very interesting talk. So actually you found that you use moisture can only quench the fire on the surface. But very interesting, in my experiment I just pour a bottle of water. It turns out you can only quench the fire on the water, because heat is porous. The water just passes through everything. So everything above is burned. So maybe there are some very good optimist side of this rocket and quench the heat fire literally better. Maybe something can do.
Yeah. Actually, we haven't measured the size of the particle of water. Maybe for the next work we could done that.
Maybe that's also where they choose the porosity of the particle sample.
Yeah.
Thank you, Guillermo Rein from Imperial College. Thank you, very interesting. So I have two comments, one question. First is, you are the only one in the whole world who's doing this. So congratulations, and I would support. It's really difficult to move into such a new. So probably a lot of people who are new to the topic have questions about what is the droplet size. The important thing is this is a new brand. Second question is, your peak temperatures are quite high. Are you sure you're not measuring the temperature of the igniter?
Oh, actually, we have quite distance is about 15 millimeters distance between the coil igniter with the thermocouples.
Okay, it's just that when you turn off the igniter, the peak temperature at a time drops really quickly. So maybe you're not measuring the temperature of the igniter, but you are definitely measuring on the region of the igniter. Whereas your other temperatures are more in the range of 500 maximum. Yeah. And the other comment that I have is, so you report 6 liters per kilogram of peat. Have you compared these to our experiments where we were doing suppression of smoldering coal?
Oh.
And is the value relatively similar, close, and different? And this actually goes with Sinjan's comment, is that we look into a spray, much thicker spray than yours. It was like a shower, we call it actually. And we also want to use a hose, and we have an intermediate size. And do you have thought on this, or how it's linking the question of Sinjan with previous work?
Actually, we haven't compared these results to the smoldering conversion of coal.
The suppression.
The suppression process of the smoldering of coal.
That's fine. That's the answer.
All right.
Don't worry. No, don't feel bad. I didn't mean that. So. Okay, no, don't worry. We'll talk later.
We have another question.
Yeah, I was wondering, so you have this difference between the short suppression and full suppression. And do you like measure a specific time to full suppression, or do you just keep it longer?
We measure the time needed using the data acquisition for the thermocouples, so that we could calculate the time when the temperature measured is below the criteria that we've.
Yeah, below the two temperatures.
Yeah.
You're saying. Because it looked, I just from your graphs, when I didn't really get enough time to look at it, but it looked like the short suppression also went below the necessary temperature, but then reignited again. So
Okay.
it needs to be below it for a certain amount of time before it's fully suppressed.
Actually, we decide when the pit has already suppressed, when all of the temperature measured is below the criteria. But when the source suppression conducted, it is only some of it. Not all of the thermocouples get temperature measurement below the criteria.
Okay. Sorry, I think I just misread the graph.
Any other questions?
Yeah.
Alison was still no university. I was just wondering your solution slide. You say the reignition phenomenon happened almost in every sample. Did you have some samples that didn't really go with the
Maybe it's this type. It should be all the sample that we tried.
Okay.
In your experiments, how did you control sample moisture? And in sample preparation, did you control sample density and porosity? Because I would expect that it has truly different results in terms of oxygen availability, heat transfer.
Actually, for the sample preparation, we use the dry pit, which is the moisture content is about below 10%. And to maintain that moisture content, we place the pit in the open area so that it could be stable first. But for the density and for diameters, we did not maintain that properties for this experiment, so that we only want to compare the different samples, and we get the very different properties, so that it could represent the size of particle diameters and also the density.
All right, let's take our